Hi, my name is Aaron Setoff. I'm a senior application scientist here at LI-COR Biosciences. Today, I will be going over a short hardware overview of the LI-6400 and LI-6400 XT photosynthesis systems. The LI-6400 is comprised of a console, cables, and a sensor head. We'll be dealing with each one of these individually as we explain the basic hardware feature of these three components. The chemical scrub tubes are on the left side, or this side, of the instrument console. The chemical scrub tube that air encounters first contains soda lime, which is used to remove the CO2 from the incoming air stream. The second chemical scrub tube houses the desiccant. The desiccant is used to remove moisture if it is needed from the incoming airstream. In both cases, a manual valve is used to direct air to either go through the column or to bypass it by turning the top knob here to either full scrub or full bypass, depending upon what your needs are at the time. It is important to note that in the case of soda lime, it is generally set to either full bypass, or when CO2 control is desired, it should be set to full scrub. In the case of the desiccant, this top valve may be set anywhere between the bypass and scrub positions, depending upon the moisture management that is needed for the chamber. We'll now talk about the CO2 source assembly that goes on the side of the console. Here is where the 12-gram liquid CO2 cartridges are housed. Once a cartridge is pierced, please note that it will last for approximately 8 hours, regardless of whether or not CO2 control is actually used in the instrument. Some other features of the CO2 source assembly include the filter here, which filters this incoming CO2 and should be replaced after about 25 or so cartridges. Additionally, there is a gasket here that needs to be in place if the instrument is going to be able to successfully supply and thus control CO2 in the airstream. Once the CO2 cartridge has been pierced and the top cartridge holder tightened sufficiently, the CO2 source assembly can be attached to the side of the console by holding the top of the CO2 source assembly and then just simply guiding it into place and holding the top while the two screws allow tightening of the CO2 source assembly to the side of the console. Once both sides are adequately tightened, the CO2 source assembly should be successfully attached. If you have an LI-6400 XT unit, the instrument will be equipped with a PCM-CIA expansion card slot on the back of the instrument console. Once open, you can install either a memory expansion module or an Ethernet adapter card that will allow the instrument to have data download capabilities over Ethernet and be controlled remotely over an internal network. Next, I'm going to point out some of the connections that are available for use on the right side of the instrument console. Here you will note that there are connectors that lead from the console up to the sensor head. These connectors are important for proper instrument operation. On this side here is the erga cable, and this is the chamber cable. Note that each of these cables features a D-pin connector that cannot be used in the opposite connector, nor can it be turned upside down or rotated in any way. In other words, they have a very definite polarity in terms of how they must be inserted into the instrument console. Once the proper fit, or once the cable is properly inserted into the connector, screw the pins tight on either side to ensure that good contact is made between the metal connectors of the cable and the metal contacts of the console. After the cables are connected, the next thing to connect will be the air hose cables. There's an air hose for both the reference and sample ergas of the instrument. Note that the sample air hose has a black ring around it. This black ring should match up with the black circle that is behind the sample air hose connector on the console. Failure to connect the air hoses properly will result in strange instrument results when flow is turned on. Finally, I would like to note that there are battery slots for powering the instrument at the bottom of the console. Batteries can be inserted directly into these slots like this, and then connected to the battery terminal connection right here on the bottom of the console. Normally, it is advisable to operate with 2 batteries. That ensures the most reliable and longest term instrument operation under battery power. However, if you wish to power the instrument off of AC mains power instead of a battery, you can use the 6400-70 AC adapter, which will go in the place of one of the batteries in the battery holder slot in the bottom of the console. You can simply plug the cords from the AC adapter into the battery terminal slots of the instrument console and power the instrument directly off of AC power. Next, I will highlight some of the hardware features of the LI-6400 sensor head. The first thing to note is that at the rear of the sensor head there are several connectors. These connectors have to be securely connected for the instrument to properly operate. First, there is the erga connection cable. This is a round cable that has a definite polarity. In order to connect this cable properly, the 2 red dots on both the connector as well as the connector on the instrument side must be lined up and properly connected. The chamber cable has a D-pin connector that has to have 2 screws thoroughly screwed in on each side in order to ensure proper connection of this particular cable. Note that there is an additional cable in this case. That is because we are showing an instrument with the 6400-40 leaf chamber fluorometer. Not pictured here is a cable that connects from the back of the erga cable onto the instrument in this large D-pin connector at the top of the instrument console. Air hose connectors are located here at the back of the instrument. Note that once again it is important to connect the sample air hose line to the sample air hose of the chamber head, as well as the reference air hose line to the reference air hose of the chamber head, or instrument sensor head. The sample air hose is designated by the 2 black markings on the sides of the air hose. Some additional features of the sensor head include the following. On the sides of the sensor head are 2 devices with little fans on top of them. These are the thermoelectric coolers. They either raise or lower the temperature of the air that circulates inside the chamber around the leaf. This tube here in front is the exhaust tube. It allows chamber air to exhaust into the match valve, and in normal operations it allows the air to exit the system. This is the chamber or leaf temperature thermocouple. This thermocouple needs to be arranged in the center of the leaf chamber and pushed up so that the top loop of the thermocouple is slightly above the bottom plane of the gasket, which ensures that the sensing bead of the thermocouple is allowed to make good contact with the leaf and provide users with an accurate estimate of leaf temperature. This sensor on the side of the sensor head is a quantum sensor. It monitors external PAR, or external photosynthetically active radiation. That allows users to know how much light a leaf might be receiving, especially if you are taking survey measurements. Note that there are 4 screws at the front of the instrument sensor head. These, when removed, these allow the chambers to be changed. So if a user desired to remove the fluorometer and put on a different chamber, such as our 2x3 chamber, you would remove these screws and be able to pull off the top and bottom plates of the sensor head. You would, of course, have to take care to remove or pull out the leaf temperature thermocouple and potentially remove this connection of the exhaust air hose before you'd be able to successfully remove the bottom plate off of the instrument. Another important feature to note is the chamber tension adjustment knob. This knob is important to adjust so that the chamber leaf gaskets have the appropriate amount of tension on the leaf when taking a measurement. The desired amount of tension allows for good contact with the leaf while not allowing for leaks, but at the same time, you want to avoid having tension that is too high that can in turn damage the leaf. When the instrument is not in use, or after measurements are completed, the chamber tension adjustment knob should be loosened so that there is a little gap between the top and bottom gaskets so that they do not compress while the instrument is in storage. This completes our brief hardware overview of the LI-6400 and LI-6400 XT photosynthesis systems. Further videos are available at the LI-COR technical support site, and additional resources are available at the technical support site as well. Additionally, you can contact LI-COR directly if you have questions, or your local distributor, depending upon the country you are located in.